3.4, number 141, is a perfect example of one of those last two derivative formulas that I said that you should just go ahead and memorize. Let me write them down. The derivative with respect to x of, you could do just a to the x or a to the ugly. If you have a to the ugly, then the derivative is going to be same a to the same old ugly times the derivative of the ugly. That's just like e to the x, the derivative of e to the ugly is e to the same old ugly derivative of ugly. Only when the base is not e, you also have to have as a factor the natural log of the base. So that's one of the formulas you have to make an effort to memorize because you're not going to have a whole lot of problems to practice. Yes, sir?
It's kind of similar to the natural log, though, if you look at it, because if you had natural log in there, it would just be natural log of e times u, so that's...
Yeah, they're all related. All right, and then the other one, you know that the derivative of natural log of x is what?
I have a question, please.
Hey, hold on just 1 second. Derivative of natural log of x is what? 1 over x. The derivative of log base anything else of ugly is still 1 over same old ugly. But you have natural log of the base in the denominator, and then you have the derivative of the ugly. So those are the two formulas that you have to memorize. Now, what's that question?
On the first one you just wrote down there,
Yes, sir.
that's going for A can be anything, right?
Yes. If you have base E, you could even use it for base E, but right here you'd have natural log of E. And what is natural log of E? 1. So whether you have E or any other base, this is the formula for differentiating exponential functions.
That's only for complex and not whole integer exponents, right?
I don't understand what you mean by complex.
With a variable.
I still don't understand. A is a constant. It doesn't have an x in it. It's just a constant, any constant to some big ugly. The variable is going to be in your exponent. Yeah, the variable can be in your exponent. It's not going to be part of the base, or you're using the wrong rule.
So that only goes for whenever you do not have an x or anything like that with your constant, which is your a. Right? So it's like 5 raised to the x plus 1. That's what we would use.
Yes.
What if it's 5 to the x?
Then it would be 5 to the same old x times the natural log of 5. The derivative of the x would just be 1. So 5 to the x, natural log of 5.
Yeah.
And the other one's for any logarithm you give us.
Yes. Log base E, natural log, is just a simple version of this. If you had log base E or natural log, you'd have 1 over natural log of E times ugly times the derivative of the ugly, but natural log of E again would just be 1. All right, let's try that 141 now. It looks pretty bad. Page 163, 141 is log base 2. Now, I just thought of another resource that you have, in addition to everything I've posted on iTunes and Momentum and CalcChat. You also have good examples in the book. And there's an example similar to this that says if you have the log of a product or the log of a quotient, rewrite it using your properties of logs that you learned in college algebra. Now this first step, I'm not doing any calculus. I'm just rewriting this as log base 2 of, how can you split the log of a quotient? Subtract 2 logs. So log base 2 of x squared minus log base 2 of x minus 1. All right, there's one other thing you could do that makes the problem just a little bit easier. If you wanted just log of x instead of log of ugly, what could you do with that too? Bring it out front as a coefficient. And then you don't have to use the chain rule on that first term. Now, that's just algebra. We have yet to do any calculus. But I think that I've written that as simply as I can, so now it's time to find the derivative. F prime of x, if you have a constant times a function, keep up with the constant, differentiate the function. So I'm going to keep up with the 2, and then I'm going to say this formula right here, log base 2 of x, the derivative of log base 2 of x is 1 over the ugly and the natural log of the base go in the denominator. So the x and the natural log of 2 go in the denominator. And then the derivative of the x is just 1, so I'm not even going to write it. This is just a constant times the derivative of log base 2 of x. Similarly, for log base 2 of x minus 1, that formula would give me 1 over same old ugly times the natural log of the base, which again is 2, times the derivative of the ugly. Well, the ugly here was x minus 1, so what's the derivative? 1, and I don't even have to write times 1. Now, any questions before I continue?
No.
Okay. Then, this is not too bad to simplify, so I think that probably in the back of the book they will have it simplified. I want you to go for single fraction simplified as much as possible unless specified otherwise. Now, if you had a derivative that had cosecants in one term and tangents in the other term and natural log in the third term, you don't have to get a common denominator for that and write a single fraction. But look how pretty easy this is. That 1 over natural log of 2 is just a constant. I don't know what it is, but it's just a number, 1 over natural log of 2. So I could factor that out of both terms and have this 2 in the numerator over the natural log of 2 that I'm factoring out. Again, I don't know exactly what this number is, but it's a constant. So I'm just factoring out a constant, and inside the brackets that leaves me 1 over x minus 1 over x minus 1. That's too easy to combine to not do it. If you multiplied the first term by x minus 1 over x minus 1, then that first numerator would be x minus 1. And if you multiplied the second term by x over x, the second numerator would just be x, and they would both be over the LCD. So this, that's a 1. First fraction was multiplied by x minus 1 over x minus 1. Second fraction was multiplied by x over x. So x minus x is 0. All that leaves in the numerator is negative 1. If I multiply that negative 1 times this negative 2, or times that 2, I'd have negative 2 over natural log of 2 times 1 over x times x minus 1. And either that is how it will be written in the back, or you really don't need those brackets.
I was going to ask earlier on when that 2 was up there, why would the brackets there?
Yeah, you don't need them. I use parentheses and brackets sometimes when they're not necessary, just to make my eyes focus where they need to focus.
Why is that 2 and negative now out in front?
Well, at first it was, I only factored, wait, holy cow.
Yeah, that's what I'm saying. Those
Cow,
brackets.
oh, snap. Actually, it's fine to have the brackets, but I closed them in the wrong place. Man, first problem I did. I'm always going to mess up the first problem or the last problem. Hopefully everything in between will be right. I can't promise that it will be. It's hard to do an hour's worth of calculus without making a mistake. What I can promise you is I'll never miss 10 out of 20. All right, so that's the goal on the test. You can make a couple of mistakes, but please don't miss 10 out of 20. All right, here's what's wrong. And Warren, next time you notice, tell me before I go on and on and on.
I was just wondering if it would come out to be the same thing.
No, heck no. No, it wouldn't be the same thing at all. This 2, everybody listen, this 2 was just the coefficient of that log base 2 of x. So when I differentiated log base 2 of x, those brackets should have closed right there. It wasn't 2 times this whole thing. It was just 2 times log base 2 of x. So my open bracket was fine. My closed bracket was in the wrong place. And that significantly changes the answer. Probably change, let's see. Let me recopy it right here. Here's where I got back on track. Does anyone have any questions up until that point?
Just give me 1 second. Let me look at that.
Okay, I didn't use the product rule. I didn't need the product rule because I just had a constant times a function.
Oh, that's where you. Is that where you took out? No, it's not. Never mind.
This is where
Okay.
That's where I should have closed the bracket. The only difference it makes is this 2 is just in the numerator of this fraction, not the numerator of the whole thing.
Okay.
And so when I factor out natural log, or 1 over natural log of 2, I just can't factor the 2 out because this numerator is 1. That will leave me 2 over x minus 1 over x minus 1. And it's still not difficult to clean that up, to write it as a single fraction. And I'm going to do that real quickly and trust that you know how to add fractions. You should. That will be 2x minus 2 minus x over the LCD. And then 2x minus x is just 1x. And so that numerator is x minus 2. And the denominator, you could write it, the denominator of the whole thing is x times x minus 1 times the natural log of 2. You could write the natural log of 2 at the beginning or the end. The reason I didn't write it at the beginning, if I had, I would have needed parentheses to be very clear that this x wasn't part of the argument of log. All right. That's 141. What's next?
Did you do 41?
I heard 63 from what, Sarah? Same page? 3.4, number 61. 63. I'll get it right before I pick up my pencil. Okay. 3.4, number 63.
I can't quote what they said, but I can't get their final answer.
Okay. I remember writing you a big hint in class flip back in your notes and find that hint where I said if you have a trig function to a power, you should rewrite that function with the power outside parentheses or brackets. It wouldn't be sufficient to put the 2 as the exponent outside parentheses, because then I'd be saying the 2 theta was squared instead of the sine that's squared. If I mean the sine is squared, then I'm going to have to use brackets with the exponent outside. Now really, no matter how scary that looks, it's just 1/4 ugly squared. What is the derivative of 1/4 ugly squared? 1/2. What? Same old ugly. Now that's to the first, and then what? Derivative of the ugly. All right, what is the derivative of sine 2 theta? Cosine 2 theta. But then what? The derivative of the 2 theta. Hey, folks in Harriman, I really don't think that you need to be talking at the same time I am. Even if you're just helping somebody, I understand. But while you're helping someone else, both of you are missing what I'm saying. And your next question is going to be, what did you just say? So help your friends before class, help your friends after class. Don't help your friends in class. And Miss Sarah now. Oh, Sarah, did you have sine theta or sine 2 theta, cosine 2 theta for the answer, and then they had something different in the back of the book? Okay, let me tell you this. If you had this on the test, I'd be so proud. It's 100% correct. Yes, it may clean up to be something more special if you remember the double angle formula for sine and the double angle formula for cosine. I don't wag those around in my head, so I don't expect you to wag those around in your head. I'm totally okay if you have sine 2 theta, cosine 2 theta. I happen to have sine 2 theta memorized. I don't have cosine 2 theta memorized. So, yeah, we could look it up, but it's not necessary as far as the test goes. That's fine. Next question.
I have one about that same problem.
Oh, yes.
Back in the beginning of that problem.
Right here?
Yes.
Okay.
How did you get to the next step?
From here to here.
Yes.
And you weren't one of the ones talking while I was writing that, right?
I didn't want to interrupt you because you don't like people doing that. So
No. I wish we were all live together in the same room so you could tell when I'm angry and when I'm not. The only thing that bothers me is when you miss what I'm saying because you're talking to somebody else. Even though I understand you're just helping somebody else, you're still missing what I'm saying here. So don't worry. I'm not angry otherwise. Let me talk through it again. This is, when I see this, I'm imagining that horrible picture of Nick Nolte right here in place of the ugly. This is just 1/4 ugly squared. And the derivative of 1/4 ugly squared, you multiply the 2 times the 1/4, that's the 1/2. Same old ugly, sine 2 theta. And then the cosine, or excuse me, the derivative of the ugly. The derivative of sine 2 theta is cosine 2 theta, but then you also have to take the derivative of the 2 theta. That is a times, not a minus there.
Why do you multiply 1/4 and 2?
What would you do if you didn't know u stood for anything and I just said, what's the derivative of 1/4 u squared? What would you do?
I have no idea what that just meant.
No, if I just gave you this problem, if this was the whole problem, take the derivative of 1/4 x squared, how would you do it?
That's my problem.
Oh, this would be the easiest problem on the test. How somebody help me? How do I differentiate that? Multiply the exponent times the coefficient, subtract 1 from the exponent. So 2 times 1/4 is 1/2 x to the first.
I got you.
Okay. All right.
It helps when you have somebody explain.
We're all friends. We're good. What else?
Did you do 41?
41 from same section?
Yeah.
Okay, let me tell you this. 41 is one of the ones that I put on yesterday's video. I knew, let me double check. Yeah, that one's ugly. So I put it on the video. If you want to see that one, watch the video part 3. Has that problem? Or you could print out the notes that I made along with the video, and I have it worked out on that. And it's also in Calc Chat because it's an odd problem. So let me do a different one that you don't have so many other ways of getting. What else? Warren, what did you say?
Number 57 on the review.
From the chapter review?
Yeah, I just want a quick review of the equation of the tangent line, basically, and that looks like it would be the best one to do it.
All right. So chapter 4 review. Yeah, chapter 3 review. Number 57. I'm still getting there. All right. This is page 198, number 57. One 59 is actually uglier, and you said you just wanted a review of the equation of the tangent line, so either one of those would work?
Okay.
Okay, let me say one thing about 57, and then 59 is the one that I'll finish. Because it has trig in it.
Oh, okay. Because I was like,
That's just your...
I like trig better.
Oh, you like trig better than algebra? When did that happen?
That derivative was really easy to take.
Okay, let me ask you something about 57. Is there a way that you could write that so that you didn't have to use the product rule or the quotient rule? How?
Put x up there to the -2.
And then multiply.
And then distribute it. All right, that's one way to think of it. Write this as 2x cubed minus 1 times x to the -2, and then distribute the x to the -2. In my opinion, that's the harder way to do it. I would have just said 2x cubed divided by x squared is 2x, and then -1 over x squared is -x to the -2. So I would have rewritten the problem in one of the two ways that you said, and then found the derivative. Now, what does the derivative give you? I'm not saying what is the answer to this problem. I'm saying what is the derivative?
The slope of the tangent line.
It's an equation to find the slope of the tangent line at any given point. Now, on 57, I was given the point 1, 1. So I'm going to find the derivative, substitute 1 into it. That'll give me the slope of the tangent line. And then if you ask me for equation of the tangent line, what do I do? Point slope form. I have the slope. I have the point 1, 1. Plug them into point slope form. All right, so let's do 59 all the way through. It may not be difficult, but we need one good example. There is one problem on the test that says find the equation of the tangent line. By the way, on the practice test that I put in the practice folder in Momentum for you, I've given you the exact format of the test. Number 1 says find the definition or find the derivative by the definition. You know what I mean by that? Use the limit as h goes to 0 of f of x plus h minus f of x divided by h. That's
Yeah, it
That's-
does. It does me a little too.
You're used to delta x, same thing. All right. So number 1 on the test, you have to use the definition of the derivative. If I give you a very easy function and you just use a shortcut and tell me the answer is 2x, it's wrong.
It's a good way to check your.
Yeah, it's a good way to check your answer, but I want to know that you know the definition of the derivative.
When you're working that out, do you keep the limit as h approaches 0 all the way through?
Until when? Until you put 0 in the place of h. All right? And then number 2 through, Kayla, what do I say on the practice test? 2 through what? Just say find the derivative.
15.
2 through 15, just say find the derivative. And then 16 or 17 says find the equation of the tangent line. So that's what we're doing on number 59. One of those, somewhere, says find the equation of the tangent line.
It's number 18.
All right? It's going to take the product rule because this is not just a constant times tangent, it's negative x times tangent. So if a little dot would help you to remember to use the product rule, put it. If you don't need it, fine. Use the product rule. The first factor times the derivative of the second. What's the derivative of tangent x?
Secant squared.
Secant squared x. So that's the first times the derivative of the second. Here's the second times, what's the derivative of the first? Negative 1. I hate that I had plus negative 1, but I had already written down the plus.
Do that.
Otherwise, I would have just put minus tangent. Now, if I could clean that up easily, I would, but I really don't want to worry too much or spend too much time about cleaning it up because I'm not supposed to just give the derivative here. I'm supposed to find the equation of the tangent line. I could put 0 in the place of all these x's in this form just as easily as I could some simplified form. So remember, the words help you. Write them. I promise they help you on the test. They talk you through the process. What we're doing now is the slope of the tangent line at the point 0, 0.
So the second thing you did right there is our derivative.
Yes, and I left off the accent. Yeah.
Okay. All right.
Yes, thank you for telling me that. The slope of the tangent line. Now, let me ask you one other thing. This problem gave me the whole point to use. What if it had just said find the slope of the tangent line or find the equation of the tangent line when x equals 0 and it only gave me the x? Where would I get the y?
From the original function.
Put the 0 into the original function because we're talking about the graph of the original function, not the graph of the derivative. So if they hadn't given me this y, I could have found it by putting that x into the original function. Since they did give me the whole ordered pair, I need to just find the slope is what I get when I put 0 into the derivative.
See, that's how I write it. Instead of like writing slope of the tangent.
Keep those comments to yourself, Miss Ashley. We're just flying today. All right.
Question.
Yes, sir.
If you put 0 into the original function, wouldn't that come back undefined?
No, I can find the tangent of 0. I can't find the tangent of pi over 2.
I looked at a wrong problem. Sorry.
Okie dokie. So 0 into the derivative would be negative 0 times secant squared 0 minus tangent 0. I know that tangent 0 is 0. I just need to make sure that secant squared is defined at 0. This whole thing's not going to be 0 if that's not defined. So I'm thinking about 0 radians on the unit circle. 0 radians on the unit circle. The point is 0, 1. Secant's the reciprocal of what? Cosine, and cosine is which coordinate? X. The x. So the reciprocal of the x here is 1. And so this is 0 times 1 is 0. Minus 0 is 0.
our slope is 0.
Correct. And what does that tell you about the tangent line?
The x-axis.
It's a horizontal.
It's a horizontal line. If the slope is 0, it's a horizontal line. What is the equation of the horizontal line through the origin?
0.
That's not an equation. Y equals 0 is an equation. You could use point slope form if you wanted to, but that would be the harder thing to do, the easier thing to do. And yes, Miss Ashley, that is 0 over 1, but 0 over 1 is just 0. So the easy thing to do would be to say this is a horizontal line. Through the origin, and so the equation of the tangent line would be y equals 0, better known as the x-axis. So maybe, Warren, 57 might have been a better example because it's not just a horizontal line. But if this had been something other than 0 or undefined, I would just take that slope, the point I was given, and substitute those numbers in the point slope form. So you're okay?
Yeah, I understand now.
Okay.
I'm just making sure. That's why I thought it was, but I wanted to make sure that I understood.
All right. Extraneous comments. All right, next.
Can you do 35 from the chapter review?
35 from the chapter review. Ooh, yay. Tell me this. If you give me the position function and I find its first derivative, what have I found? The velocity function. Ooh, for 10,000 bonus points, if I take the absolute value of the velocity function, what does that give me? The speed. Yes, speed is the absolute value of velocity. And then if I find the second derivative is what? The acceleration function. So let's see what 35 says. To estimate the height of a building, a weight is dropped from the top of the building into a pool at ground level. How high is the building if the splash is seen 9.2 seconds after the weight is dropped? Holy cow, I should have done this one before class, because now I'm actually going to have to think. The fact that it says dropped instead of thrown tells you what?
Go straight out.
It tells you that the initial velocity is 0. All right? Dropped means the initial velocity is 0. And my position function, and I wish I could convince you how much writing these words helps. You're actually thinking through the problem instead of hocus-pocusing your way through. The position function, if we're talking about feet and seconds, it's s of t equals negative 16t squared plus the initial velocity times t plus the initial height, and what do we usually use for that? S sub 0. Yeah.
How do we know that?
We've done it enough that I would hope that it was stuck in your head, but honestly, on the test, I would give you that.
Okay.
You're gonna memorize.
Do we have to know that stuff?
What did I just say?
You'll give it to us. Like that,
Okay.
the acceleration, the speed, all that you'll give us then?
I will give you this. You have to know, listen to me. You have to know that the first derivative of the position function is the velocity function, and you have to know that the second derivative of the position function is the acceleration function. All I would give you is this formula so that you didn't have to memorize it. Now,
Okay.
the fact that the initial velocity is 0 means this middle term is gone, and my position function is just negative 16t squared plus the initial height, but I don't know what the initial height is. That's what I'm trying to find out. The only other thing I know is that, let me find the problem, the splash is seen 9.2 seconds after the weight is dropped. What is that really telling me?
That
At
at that
9.2
time,
seconds.
it's hitting the ground.
That's beautiful. That's beautiful.
Impact.
When t equals 9.2, the height is 0. This was a weight hits the water when its height is 0. Now, how do I use that information?
Plug it in.
Plug now 0 in the place of the height, 9.2 in place of the time, and I'm not even going to have to use calculus here. This is not even a calculus problem. Let me read it one more time. Yeah. How high is the building? We don't need velocity or acceleration for that. We just need 0 equals negative 16 times 9.2 squared plus the initial height. What is 9.2 squared times 16, somebody?
Oh, okay, sorry, I read what you wrote down.
I'm sorry, what?
1,354.24 feet.
That's the initial height of the building.
Can you explain to me what you just did? You lost.
Okay, look up at the paper and ask me a specific question. What is it that you don't understand? I punched that on the calculator.
You made it 0 equals.
Because when the weight hits the water, what is its height?
0.
That's why I let S be 0.
But
And it hit the water in 9.2 seconds. So I put 9.2 in the place of t and 0 in the place of the height and solved for the initial height. That was the answer to the question. Just
So the
how high is the building?
The initial height is what's in the function itself. The s to the 0. S would base
Not
0.
not to the,
Base.
because that sounds like an exponent, but S sub 0. Yes, that is the initial height. I'm sorry, what?
That's the initial height.
Correct.
And the s of t is the height we're looking for.
No.
No?
The problem says, what is the height of the building? Here's a picture, and pictures are very helpful sometimes. Here's the building. Here's the swimming pool. The weight was dropped, not thrown, but just dropped from the top of the building. And so its initial height is the same as the height of the building. And that's what we're looking for, the initial height. This S of t is the height at any given number of seconds. So at 9.2 seconds, that height is 0.
Okay, so that's why we said 0 equals.
Correct.
Alright. Alright. Okay, I'm following it a little bit better then.
Okay. Now, this particular problem, maybe if we didn't have that memorized or it wasn't given to us on a test, maybe we wouldn't even have used calculus because we don't know how to anti-differentiate yet. I don't know how they wanted us to do that problem using calculus because it actually didn't take any calculus. That's just
I
algebra.
think it was just
Yes.
the position function.
I added 1,354 to both sides to get the S sub 0 by itself. This would have given me a negative, and then I added it to both sides to get that by itself. All right, next question. 34 from the review. Okay, 34 from the review. Another motion problem, right, John? Okay, just making sure I'm looking at the right thing. Number 34 says a ball dropped from a height of 100 feet, or a ball is dropped from a height of 100 feet. That tells me two things. In the position function, that 100 feet is the initial height, and the fact that it's dropped, not thrown, gives me the initial velocity is 0, so I don't need that middle term. For this problem, the position function is just going to be S of t is negative 16t squared plus the initial height. Again, because dropped means the initial velocity is 0.
Right.
All right, then what? 1 second later, that means when what? Okay, hang on. This is two different balls.
Yeah.
A ball is dropped at a height of 100 feet. We need to say that's the position of the, I'm going to use this, for the S of 1 is going to be my position of the first ball. This means first ball. And then the second ball is dropped from a height of 75 feet. So 75 instead of 100 right here. But what is it going to change? What is the fact that I'm dropping that ball 1 second later? How is that going to change its position function?
The time's going to be minus
Second
1.
to the time.
T would be
Instead
plus
of t, 1 second less would be t minus 1. So this is the position of the first ball in t seconds. This is the position of the second ball in t seconds, but this number of seconds is 1 less than that number of seconds. And then if the question is which ball hits the ground first, set them both equal to 0 and see which one gives you the smaller answer. So negative 16t squared plus 100 equals 0, and negative 16 times t minus 1 squared plus 75 equals 0, and whichever one gives you the shorter time is the first one that hits the ground. And I'm not going to take time to do that algebraically because, again, this is a college algebra problem. It would be more difficult than I would give in college algebra, but it actually doesn't require any calculus. That's just solving two quadratic equations.
I was just getting kind of bogged down in the
Yeah.
equations.
Yeah, that was the hard part. The setup was the hard part. Miss Sarah?
Because I did it and I just added 1 onto it.
You know, that works also, and is probably an easier way to solve it. No, this ball is traveling 1 second less than the other ball. This ball is going a full t seconds. This one's going 1 less than t seconds.
Because you waited a second?
Yes. Yeah. Like if this one takes, if they hit the ground at the same time, and let's say it's 5 seconds, then this one actually went the whole 5 seconds. This one actually was falling only 4 seconds because it was dropped a second later. All right. Remember, hardest problem is never going to be the one on the test. Okay, what else?
3.4 under 101.
Going back to 3.4, what page number was that? 163?
It's about like 101, 103, and 105. They have
Okay.
absolute value, and I'm not sure.
Oh. Okay, let me tell you something. You may not actually need to see this whole problem worked out then. 103, 104, and 105, they're all ugly because they have cosines and sines and natural logs of secants and tangents. I actually did 104 on yesterday's video if you want to see it. But what I say in the video about those 3 problems, the absolute values don't affect the derivative at all. You can play like they're not there or play like they're parentheses and you'll still get the same answer. All the absolute value does is give you a wider range of x values you can use, because without those absolute values, I couldn't use anything that would make inside that expression negative or 0, because I can't take the natural log of negative or 0. With those absolute values there, I can let x be anything for which secant and tangent are undefined. Even if that gives me a negative, I'm going to take the absolute value before I take the natural log. So again, the absolute values symbol do not affect the derivative. It just affects the domain of that expression, what you can let x be. All right, next. Go for it, Sarah. Nobody else is asking.
Okay, number 5 on the review sheet you gave us.
Okay, is that something you can read easily? Gosh darn it. Okay.
I'm pretty sure then you have to use the double angle formula to solve that.
No, you really should. Well, you may. Let's look at it. This is 5 from the practice test. Sarah, if you do have to have the double angle formula, then I would give it to you. That's not, if I don't have it in my head after 25 years of calculus, then I don't expect you to have it in yours.
Maybe I'll do it without it.
So let's see. Number 5, the function is f of x equals 2 cosine x plus sine 2x, and I want to know where in the interval from 0 to 2 pi. And notice, this is probably a typo on my part, but I have parentheses on both the 0 and the 2 pi, which means not including 0 and 2 pi. If one of your answers turns out to be 0, don't list it. It's not on this interval. All right? If it had a bracket, then I could use it, but not a parenthesis. So, if the directions say, thank you, where is the tangent line horizontal? Tell me what you're thinking.
Well,
Slope is 0.
You're thinking, now don't use pronouns, don't say set it equal to 0, because if you say it, I don't know what you're talking about. You don't set the function equal to 0, or you would be finding what? What is it that you find when you set y equal to 0? The x-intercepts, all right? And that's a cool thing to know, but it doesn't have anything to do with this problem. So don't set the function equal to 0. Think, if the tangent line is horizontal, its slope is 0, and that means set the derivative equal to 0. So the first thing we're going to do is find the derivative, term by term. The derivative of 2 cosine x is what?
-2 sine x.
Negative 2 sine x. The derivative of sine is cosine. The derivative of cosine is negative sine. Second term, that's sine of ugly. The derivative of sine of ugly is what?
2 cosine.
Cosine, same old ugly. And then
2 times 2.
derivative of the ugly. Good job. So far, so good? Now, actually, Sarah, now that I got to this point, I think you're right. That would be difficult to solve unless there's a formula for changing cosine of 2x to something that's just sine. I don't have it in my head either, but I know where it is. I know, hang on just a second, Miss Ashley. I know where it is, and if you needed this on the test, I would give it to you. All right? So hang on just a second. I would factor out a -2 probably, because I can. And then this would be sine x minus, because I factored out a negative. You happen to have, Ashley, did you look up the double angle formula for cosine?
You just want sine, just with a.
Yes, that's the one where I had three different choices, and I would want to choose the one that just had sine in it. It is 1 minus sine squared.
Yeah, well, no.
Okay.
Yeah, sine, 2 sine squared.
Oh, really? Let me make sure I'm hearing what you're saying correctly. 1 minus 2 sine squared x. Is that what you're saying, Miss Ashley? How confident are you of that? Did you?
Yeah, I just now looked it up to make sure that I was correct.
Okay. I couldn't tell by your face if you were guessing or if you looked it up.
At first I was.
Okay. Miss Sarah?
So without using that formula at all, I shouldn't have been able to solve that. Like,
Yep.
because I stared at it for forever and couldn't.
Okay, let me tell you the Miles rules for calculus, and this is the Kirk Miles, my husband's rule for calculus, not my rule for calculus. The Kirk Miles rule for calculus is never leave a calculus problem blank. When in doubt, put either -1, +1, or 0, and you have a decent chance at getting it right. So Sarah, if you were able to solve this one or without using the double angle formula for cosine, my guess is that the answer, everything inside parentheses or brackets, was probably -1, 0, or 1. Because that would be the only way that I could squint hard enough to figure that out without using the double angle formula. So, no, I expect you to have used everything on this page enough to have it memorized, except for these two, and those two I expect you to memorize it just long enough to write it down on the top of the blank paper I give you. I expect that you would have quadratic formula memorized at this point in your life. And Pythagorean theorem, I can't imagine why you would need it on this test, but I expect you to have that memorized. Things like double angle formulas, half angle formulas, sum to product, product to sum rules, I don't wag those around in my head. I know they exist, and if I need one, guess what? I don't even open a book. I Google it. Double angle formula for cosine, boom, there it is. So if you need something that I don't think it's reasonable to expect you to have memorized, trust me, I'll give it to you. But there are things that I think it's reasonable to expect, such as quadratic formula by now. All right, next question. We have, it looks like about 7 more minutes, so I can do 7 more minutes worth. And then those of you who can make it tomorrow afternoon, I'll see you. Those of you who can't, I would encourage you to watch the video. Next question.
97 on 3.4.
3.497. Alrighty. Yeah, that's pretty ugly. There's something that'll make it less ugly, though. It's not going to be cute no matter what you do. But this will make it a little less ugly.
They say chapter review or
3.497. Now, obviously, I'm going to have to rewrite that square root as the exponent 1/2 because I don't have a formula for differentiating a radicand, or excuse me, a radical. But I do have a power formula. If I write that as natural log of x plus 1 over x minus 1 to the 1/2, then I could use the chain rule. Or maybe I could rewrite it so that I didn't have to use the chain rule. You want to do any more algebra there before you hit the calculus?
Yes, definitely.
I would. You could bring that 1/2 out in front of the whole natural log and then separate this quotient into the difference of 2 logs. Now, I'm going to purposefully make a mistake. I like to announce when I'm making a mistake on purpose so that you know this is not me messing up again. Tell me what is wrong with this. The half was the exponent of that whole quotient. So either I need to put half for both of those coefficients, or since when I'm differentiating I can just keep up with a constant, I'd probably just keep up with it outside brackets.
If we didn't do that, we'd have. If we didn't do it like you did, would we have to put it with both of them?
Yes.
That'd be all right?
Do
That'd
you
be all
mean
right?
if you didn't use brackets?
Yeah.
Is that
yeah.
what? Then yes, 1/2 would have to be the coefficient of both of them, and I suspect that at some point you'd have to factor out the 1/2. So that's why it's easier to not distribute it to begin with. But you should get the same answer either way. All right. Here's the derivative, and I almost just kept going with my equals as though I was still just rewriting the function. Don't do that. When the calculus begins, write y prime. Keep up with the 1/2, differentiate the function. What's the derivative of natural log of x plus 1? 1 over x plus 1 times the derivative of x plus 1, but that's just 1, so I don't even have to write it. The derivative of natural log of x minus 1 is 1 over x minus 1 times the derivative of x minus 1, but that's just 1, so I don't even have to write it.
You don't have to put the natural log in the denominator.
You know what? That's a good question, Kayla. Kayla said, do I have to put natural log of the base in the denominator? What if I did? If I put natural log of the base, what is the base right here?
E.
E. And what is natural log of E?
1.
That's why I don't have to write it. But it's good to think of that. That tells me that if this had been log base 2, you would have remembered the natural log of 2. All right, so that's why you don't have to write that. Now it's just add fractions, express your answer as a single fraction. Miss Ashley, what's making you frown?
It looks like it's going to be a 0.
Let's see. This would be x minus 1 minus x minus 1. I think maybe you didn't distribute your negative completely. Because I'm going to have negative 1 minus 1 is negative 2.
Oh, okay. Yeah, no, I see what you're doing. I wrote x minus 1 twice instead of x plus 1.
All right. I do not expect you to have any trouble adding rational expressions